Can a simple equation predict the existence of aliens in our galaxy? The search is on. The Drake equation was wrote in 1961 by Frank Drake while he was preparing for his first Search for Extraterrestrial Intelligence meeting, or SETI. The equation was meant to summarize the concepts that scientists would have to answer in order for radio astronomers to find other radio communicative life in the Milky Way. Frank said, quote, "As I planned the meeting, I realized a few days ahead of time that we needed an agenda, and so I wrote down all the things you needed to know to predict how hard it's going to be to detect extraterrestrial life. And looking at them, it became pretty evident that if you multiply all these together, you got a number, N, which is the number of detectable civilizations in our galaxy. This was aimed at the radio search, and not a search for primordial or primitive life forms." So what is Drake's equation? It looks like this. N equals R sub star times F sub P times N sub E times F sub L times F sub I times F sub E times L. So we're going to break all these down a little bit because there's a lot to cover. R sub star is the rate of star formation in our galaxy. The Milky Way contains up to 200 to 400 billion stars, and the average rate of new stars is about 1 per year. F sub P, the fraction of those stars that have planets. We think it's around 100 billion. N sub E, the average number of planets that can potentially support life per star that has planets. Earth sits in what's called the habitable zone, or the Goldilocks zone, meaning that it's not too hot, or we'd look something like Venus, and it's not too cold, meaning we'd look something like Mars. It sits perfectly in between. Now, Mars and Venus are also in the habitable zone, but they're on the edge. We are perfectly in the middle. And not only that, but our moon is large enough that it helps with our tides, and we sit at a nice even 23-degree tilt, which gives us a nice all-around tan. All of this seems really rare on its own, but to have all these things line up all on one planet seems, well, it's only happened, as far as we know, once. So it doesn't get any more rare than that. But by using the data that we've collected from the Kepler Space Telescope, we think that there could be anywhere from 40 billion Earth-sized planets orbiting sun-like stars or even red dwarf stars, and all of those sit within their Goldilocks zone. F sub L, the fraction of suitable planets on which life appears. We don't know. We've only seen one, and not wanting to count ourselves, because we classy like that, we have no idea. And so from here on out in the Drake equation, we have no clue. We have no answers for any of these. F sub I, the fraction of planets with life that develops into intelligent life with civilizations. F sub C, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Back in the 60s, Frank Drake thought that the radio waves were going to be the way to go to pick up extraterrestrial life, that if they were intelligent enough to send any information, to be done with radio waves. Now we're kind of leaning towards maybe it's something that we don't even know how to detect yet, because we don't really use radio waves like we thought we would back in the 60s. L, the length of time in which such civilizations release detectable signals into space. Like I said, we don't know. All we have is ourselves to go on, and it seems like throughout history, all we've tried to do is eliminate ourselves from the equation. So it doesn't give us much hope for any other civilization. Why would they be any different? N. Now, in the 60s, they believed that there was anywhere from 4 to 10. Now, we believe that the number is more like 0.0017. Now, what this means is that on any given 100,000 year period, there should be around 127 intelligent civilizations that are able to communicate. But Drake thinks that it's more around 10,000. And that might seem like a lot, but there's over 100 billion stars in the Milky Way. This means that we would have to search about 10 million of them before we started getting any significant data on whether he's right or not on his conclusion on that. But even though Drake's equation is not complete, I don't think we should dismiss it. I'm reminded of this photo. This is Albert Einstein's office, just hours after his death on April 18th, 1955. And as I stare at this photo, I think of all the unfinished work, all the equations not yet complete. And I realize this is not a sad photo, just the opposite. It reminds us that we have so much left unlearned. And the fact that we live in a time where there are only a couple questions answered on Drake's equation is not only exciting, but it shows that this is just the beginning for our species. And where we go from here is uncharted, but we can just imagine the adventure we're going to have. So even if there are, on average, 127 civilizations that can communicate at any given time, or as Frank Drake thinks, 10,000, why haven't we heard of anybody? We don't hear any radio waves. We don't see any sign of civilization at all. And it could even be more than that. So another reason why we might not have seen or heard anybody is something that's called the Fermi paradox. And that's what we're going to talk about next week, because it's very interesting. So like and subscribe, and I'll see you next week.